Either would be great. All right. Ladies and gentlemen, today we've got metamorphic rocks, and we begin from the beginning. Now, with metamorphic rocks, you get these cool patterns and other things, and we're going to kind of talk about why. Notice in the background, like we had granite last time we did this time we have marble in the background. I tried to be a little bit rock specific here with these. Now, how are metamorphic rocks formed? Go ahead, I had a question. Oh, I'm not presenting. That creates a problem for you guys seeing what I need you to see. All right. I apologize there. So Barrett will have a funny thing to look at when he looks on the video. All right. Very good. All right, Brody, make sure you tell Barrett all about that. I'm sure he'll think it's just great. All right. So, chapter 4, section 3, metamorphic rocks. So you can see these kind of cool swirling patterns or this banding that they call it. All right. These are different things that are specific to metamorphic rocks. All right. And we see marble in the background. That's one special metamorphic rock. Now, how do we form these metamorphic rocks? Well, there is a specific way and type, and you hopefully learned about it the other day. There's going to be two things: change due to temperature and change due to pressure. Those are the two big ways. We have temperature and pressure. Usually we say heat and pressure with these. So temperature and heat, kind of the same thing. So that's how we get metamorphic rocks, is we have heat and pressure going on at the same time, and it changes the rock itself. Looking at possibly when we get back, there's a pretty cool Magic School Bus video. Sorry, I've got my kids trained to watch science stuff. On this, it's the Magic School Bus rides again. You can kind of see that, and hopefully I'll be able to bring that in and get my Netflix account up and we can watch that. That'll be the plan if we do well enough on these next two assignments. So that means everybody's got to be trying. All right. So, ladies and gentlemen, we have change due to temperature and pressure. Now, when we move on, and there's a hot watery fluid, and you can kind of see that in the picture under the diamond here. There's that hot watery fluid. Those fluids help to do that. It's almost like, think about squeezing an orange. You get those fluids out as you change the inside. Similar kind of with a rock. Okay? It cannot be because of sudden melting. Why, Blayton, cannot not be because of sudden melting? Ooh. Do you want to phone a friend, Blayton? Or did you give the answer already? Don't know. Anybody can help him out. Why can it not be because of sudden melting? Ooh. What happens if something suddenly melts, turns into lava or magma, then cools? It becomes igneous rock. So why can't it be because of sudden melting? Because then it would make igneous rock. There we go. All right, guys. You guys know these things. You got to just think about it. All right. So, and it cannot be from minerals from solutions. The reason it cannot be from minerals from solutions, if we do this, then we get a sedimentary rock. Okay? So these first three change due to heat, pressure, and these hot, watery fluids. All right. So it cannot be because of sudden melting, because that makes igneous, right, Barrett? And then this cannot be from minerals from solutions, because that would make sedimentary. Okay? So we've got all those things that we need, and now we move along. Yes. Oh, yes, we can do that. All right. So as we look at these, heat and pressure. So if we apply heat and pressure to a igneous rock, Amelia, what kind of rock would it make? I have an igneous rock, there's heat and pressure. What kind of rock do I get? Nice and loud, Amelia. I have an igneous rock. I apply heat and pressure to it. What do I get? What kind of rock? Metamorphic. All right. So, Eve, I've got a sedimentary rock. I apply heat and pressure to it. What do I get? And then Olivia Valroy, I've got a metamorphic rock. I add heat and pressure to it. What do I get? What do I get? I have a metamorphic rock. I add heat and pressure to that metamorphic rock. What do I get? No, if I add heat and pressure, I'm not going to get igneous. I will get. What happens when we add heat and pressure? Don't overthink it. When we add heat and pressure, we get what? Phone a friend if you need. Metamorphic rock. All right. Anytime we add heat and pressure, we get metamorphic. Just like anytime there's sudden melting and cooling, we get. Everybody? Igneous. And anytime we break it down into small little sediments and cement it back together, then we get. All right. Always and every time. All right. So hopefully we gave enough time. Now, what can form a metamorphic rock? Do you remember the rock cycle? Oh, anytime. Anytime we see this purple where we have temperature and pressure. Oh, sedimentary can go to metamorphic. Temperature and pressure, igneous can go to metamorphic. Metamorphic, temperature and pressure can go back to metamorphic. Anytime we have heat and pressure, we're going to go to metamorphic rock. All right, very good. All right. Any type of rock can change into another type of rock, right? All right. So, igneous can go to metamorphic. What do we need for igneous to go to metamorphic? Somebody with a hand up. Mrs. Leifer, you can call on them. Igneous to go to metamorphic. What do we need to happen? We need heat and pressure. All right. Yes, heat and pressure. Here's an example. Granite, remember granite that was an igneous rock, can change to gneiss. All right. So, granite can become gneiss. This might be important to write down. It's a different color. And if you even know how to use your notes on the homework, it might just give you an answer. So, igneous can change to metamorphic. You want to write that down? And an example would be granite changing to gneiss. Okay? We'll show you pictures of that in a little bit. Okay? So, granite changes to gneiss. All right. All right. Then, what about this? What if I have a sedimentary rock and I get metamorphic? How did that happen? Anybody with a hand up? How did that happen? Heat and pressure. All right. So yes, heat and pressure always. An example is when limestone turns to marble. Marble's a very famous one, that famous rock they make statues out of. I'm sorry. So limestone can change to marble. Ooh, another example that might just pop up somewhere else. All right, Liam, it might just show up somewhere else. So if your notes are nice and neat and you know to look in your notes, you might even just get an answer out of that, all right? And then Alan Walter, metamorphic. They changed to a different metamorphic? How did that happen, Alan Walter? Heat and pressure. It's not real hard, is it, guys? That can happen, and I don't even have an example for you. So you got the other two examples there, and I don't have one for this. All right. So, ladies and gentlemen, anytime we get a metamorphic rock, we knew that there was everybody together. Sure. Ooh. Anytime we get an igneous rock, we knew that there was everybody together. Melting and then cooling. I think I heard Colby say that the loudest. Melting is important. It has to turn to lava or magma, and then it has to cool. No, I'm sorry. Who was it? Lily. I am sorry, Lily. All right. I am sorry. Voices sound a lot different on this stuff. All right. Does anybody need more time on this page? Yes, no? Okay, that's fine. If you do, yes, that's what we got. So now we had limestone goes to marble, granite goes to gneiss. All right. That was igneous going to metamorphic, granite to gneiss, and limestone to marble is sedimentary to metamorphic. All right. There's also times when sandstone or siltstone, it changes to metamorphic. It can make a special one called quartzite, I do believe it's called. I'm just going on memory here, guys, so hopefully I'll give you a few more examples in a little bit. All right, ladies and gentlemen, heading onward and upward. So, how do we classify these metamorphic rocks? Now, yesterday, well, I guess not yesterday, Friday, we did igneous rocks. Ooh, what were the two types of igneous rocks? I do want a hand up for this one. Or let me just pick on Brody Stenzel. I think that sounds like more fun. All right, Brody S. What do we have there, Brody? What two classifications were there in igneous rock? Intrusive and extrusive. Very good job. Now, Brody named the two types there, intrusive and extrusive. Colby, why do intrusive rocks get their name? Yeah, and since they're formed inside the earth, they cool slower and they have large mineral grains and visible crystals, right, Adiron? Yep. What about those extrusive ones, Addy? Where were they made? Exit. Very good. Ooh, now does anybody remember? Let's go to Eve. I feel like getting to Eve. What kind of mineral grains and crystals do we see or don't we see with extrusive? Do you remember? No. Does somebody remember? If you remember, go ahead and put your hand up. All right, very good, very good. All right, Ty, are you getting all that? All right. Awesome. So now we have foliated, and right next to it are non-foliated. Now, I know you guys have been studying English a long time, and I know Mrs. Letcher did a really good job on that, and Mrs. Whalen's continuing that tradition. Non-foliated, foliated. So, Lucas, what do you think is going to be true about these two types of rocks? They're going to be, hmm, they got, all right. Anybody got a guess just from the words? Ooh, yes. With bands, without bands. That's a very good call. Non-foliated would kind of be opposite of foliated, right? One has the things, one doesn't have the things. Non means no. All right, yes. So let's look at them. Mineral grains flatten and line up in bands. Boom. Somebody looked ahead. Somebody remembered the research that they did on Friday. Good job. Good job. Well, then what do you think we're going to say about non-foliated? Someone with a hand up? Oh my gracious, they catch on so quick. Mineral grains grow and rearrange. There are no bands. Nice job, Kenley. Very well done. All right. Mineral grains flatten and line up in bands. Mineral grains grow and rearrange. There are no things. And that's from the heat causing the growth there. As you heat things, they generally expand. So, banding occurs, just like we said. And then, just like Kenley said, no banding occurs. Okay. And we get a look. Do you see the bands of different colors that are in there? I'll leave this page up for a while. See the bands of different colors? Well, on this one, there's no bands of different colors that are there. All right. So, foliated versus non foliated. They're side by side, like I heard Colby say earlier. So, yes, we are going to compare and contrast them. All right. We have all those necessary things. All right. All right. Okay. Oh, that's wonderful, Mrs. Leifer. Thank you for sending me those images. Ty, we're going to try to get them to you where you can have them so you can work on your stuff. All right. Oh, that's perfect. All right. All right. So, Kenley told us there was no banding. So, just like igneous, these have two different groups. Foliated means having bands, non foliated means no banding. All right. So, we've got all those. Does anyone need more time on this? Okay. All right. Very good. We'll move on then. Now, whoa, there's another way to look at that. Is this any different from the other page? Do you need to rewrite this? No, probably not. But one thing I do want you to kind of see, I'm going to put my laser pointer on since that's a cool feature I just learned how to do. Metamorphic rock. It breaks down into non-foliated, groups without bands, or foliated, groups with bands, okay? That's one thing that we can look at and we can see. So this is just another way to represent this in a graphic organizer way, okay? Or a concept map. All right, have it be. All right. So as we move on, foliated examples. So now we're going to give you some examples and have some images of them. Okay. So here are some foliated rocks. This again might help you with your homework. Guys, I'm trying not to make it overly hard, but you do have to use notes or book. It's not just going to be remember from your brain. Slate. Ooh, slate, gneiss, those are both foliated examples. So if we were to divide things down on the homework, you might want to put these on the side that say foliated examples. With slate, it looks kind of like that. You see the different colors, but there's no banding. There's no distinct lines or grooves, all right? Or there are distinct lines or colors. Excuse me, if you can kind of follow my mouse there. You can see them some there. There's a little bit of banding. All right, you can see the bands that occur within. All right, there is some banding. My fault. And then with gneiss, the gneiss is a little bit more obvious that you see the bands, don't you? You can kind of see those bands that are curled and rolled throughout there. Okay. So foliated examples would be slate and gneiss. So if you just want to write under the foliated, do examples, and then you can do slate and gneiss. That might work really good. That'll give you a heads up for what we're doing on the next part there. And then if we go on to non-foliated example, here's some non-foliated examples. Marble, which we see in the background, and quartzite. Oh, I did remember it right. With marble, you see different colors, but they're not banded together. They're just kind of spread throughout. And with quartzite, you see maybe little hints and hits of different colors, but there's no banding at all. Non-foliated means no banding. So non-foliated examples, Liam, marble and quartzite, all right? And if those are in your notes and you know what they are, boom, that's going to save you a lot of time with your homework. But please make sure you read the questions. All right. Anybody need more time on this here slide? All right, let's roll on. We are at the end. I am going to stop sharing. I'm going to